Kia ora, Year 12. This is a really good vectors question that Hugo's asked me to do, and it's from the March 2022 paper. I like it because it goes through 3 of the very common skills that we've got left in A-level for vectors. And so the first one here is that we have to find a vector equation for a line through 2 points. I've got a couple of picky little things to talk about in there. The next one, which is the bit that Hugo wanted me to go over, was how we find the acute angle between the directions of AB and the line. And we have to answer in degrees. And then the last one is our classic, show that the line does not intersect the line through A and B, doesn't intersect the line L that they've given us. So this is simultaneous equations, and as we all know, these can be a little bit painful, but in this case, the algebra is not too bad at all. Okay, so I'm going to go reasonably quickly on this. I'm going to start off by looking at these and getting them into column form. So the position vector OA is 2, 1, 1. I don't know why the stylus is doing the weird flicky thing, but it is. The position vector OB is 1, negative 2, 2. Guys, if someone's finding that really, really annoying with the little thing on the end of the stylus, please can you send me an email and I will make an effort to try and turn it off. It's just started happening today. Okay, and then we're given a line L, and it's got vector equation of this. So R is equal to 1, 2, negative 3 plus mu times 1, negative 3, negative 2. Now, something important to pick up here is that writing R equals, and sometimes, so you'll see that in bold in the text, but we can put a little line under it. That is the same as when we write the equation of a straight line, that we write y equals 2x plus 3. Right? If you just wrote for me, the line is 2x plus 3, I would tell you that that was a bit rubbish and that you really need to write it like this. So one thing that I've noticed that they've started putting in the mark schedules is that you have to write the R equals here, right? So you can't just leave that out. If you don't have that in, you chuck a mark away. So don't do that. I think most of you are doing that anyway. Okay, so what we've got to do is we've got to find another line, which is the line through A and B. So we need 2 things. We need to have an anchoring point, and I'm going to use the position vector OA, and then we need a direction vector, and I'm going to use the vector AB. So vector AB is OB minus OA, and we could draw this geometrically if we had to, but we're not going to bother, right? So we've got 1, negative 2, 2, minus 2, 1, 1. So this one here, take away this one here, and that gives me something. What does it give me? Negative 1, negative 3, and positive 1. That means that I can write the equation of the line they're asking for as 2, 1, 1. Plus, I'll use lambda, but you could use t or s or anything else that you wanted. Okay, and so what this means is this is a parameter, and as this changes, I move up and down the line. So you can visualize it as being like this. Here is my point OA. So imagine the origin's down here. So we have to go from the origin up to that point, and then we're on, I don't know, some kind of zip liney thing where we're moving along here, right? And so we know that B is also on that line, and we can trace out points along that line by changing the value of lambda. You're not asked for any of that here, but that's the way that I like to think about it. In the next question, we have to find the acute angle between the directions of AB and the line. So all I have to do here is work with the direction vectors of the 2 lines. And I'm going to use this result, which is that the cosine of the angle, so we've got the 2 vectors here, then cosine of theta will equal the dot product of the 2 vectors scaled by their magnitudes, right? So this one will be 1 squared plus negative 3 squared plus negative 2 squared. And this next one will be negative 1 squared plus negative 3 squared plus 1 squared. Now you don't get particularly nice numbers here. That scalar product works out to be negative 1 plus 9 minus 2 divided by the square root of 1 plus 9 plus 4, which gives me 14. And here I've got 1 plus 9 plus 1, which is 11. So the cosine of theta is equal to 9 minus 3, so 6 over the square root of 154, which is not a particularly lovely number. 4 is not a factor. So all we need to do now is say that the angle is inverse cosine of that yucky decimal thing. Remember, don't round this too hard or you're going to be inaccurate in your final answer. And so the acute angle between those two lines will be 61.1 degrees to 3 significant figures. So Hugo, that's the bit you asked me for, but I'm just going to go on and show that the line doesn't intersect the other line. And I think it's really important that you have some decent communication here. You don't need to write too much, but you need to explain what you're doing. So if they intersect, then there's a pair of mu lambda such that this holds. So what we're saying is that there is a solution to these three equations with only two parameters. And I'm going to label them 1, 2, and 3. So our strategy is to take any block of two equations, solve them, and then check with the third. So you can do whatever you want, but I did this one because 1 and mu was pretty easy, and then I did this one. I'm looking at that now, and actually, oh yeah, let's just do what I've done on my piece of paper. So the first one, 1 plus mu equals 2 minus lambda. I'm going to rearrange that to get lambda plus mu is equal to 1. Right, and I'll call that equation 1. Rearranging the next one, we get 2 minus 3 mu is equal to 1 minus 3 lambda. 3 lambda minus 3 mu is equal to negative 1. Lambda minus mu is equal to negative 1/3. So I'm going to call that equation 2. Now I'm going to stack them next to each other and do some year 11 maths or year 10 maths. So I've got 1 here and I've got 2 dash here. Let's add them together, and that will give me 2 lambda is equal to 2/3, giving me a value of lambda of 1/3. So I told you the algebra here was pretty good, right? Not too bad. So that's lambda, and then I can read off mu pretty easily as mu must equal 2/3. So we're just about there. We know that if there is a solution, if there is an intersection to these two lines, then it would happen at this combo of mu and lambda. But what we're about to show is that that doesn't work for the vertical component of those vectors for the k direction, right? Remembering if you've got your three-dimensional vectors, then this last one here is what we've got to check on now. Now, it's really important that you show this thoroughly. So we're now going to say, is this consistent with equation 3? Let's work out the left-hand side of equation 3. Well, we've got negative 3 minus 2 lambda, which would be negative 3 minus 2 times 2/3. That gives me a value of negative 9 minus 4, negative 13 over 3. But the right-hand side is 1 plus lambda, and lambda is 1/3, so that equals 4/3, which is not equal to negative 13/3. Therefore, there's no pair of lambda mu. Therefore, so that makes all three true. Therefore, lines don't intersect. Okay, so there you go. 3 of the basic skills that are left. This question in the March 2022, I think, was significantly easier than some of the ones we get with 3 dimensions and with geometric shapes. So over the next week or so, I'm going to try and pick off a whole bunch of the recent vectors questions just to make sure that you're feeling confident with those. If you spot any before I get time to do that, just send them through to me and I will move them up the queue. Thanks for watching.